becomes recording. Okay?
Okay.
You have to make sure that that button is available throughout. Meanwhile, you can start your virtual machine.
Yeah, I started.
You started, right? Okay, leave it. Okay. Next, very, very important section. Again, those who are looking for jobs and all will be requiring this most important Hive. Applications, most of the applications, if you look at Hadoop, it will be on the top of this Hive. Understand these concepts and then we will right away jump into some of the practicals. There will be lot of handout materials from now you will be getting. Make sure you are practicing it, okay? Because I am not going to follow that how to enable assured property in Hive. It will be some 10 steps, right? So with the screenshots I am giving you the document. So please go through that. There are no technology or nothing involved in that. There is nothing that I can give you value add by telling you this is the first point, this is the second point, you understand, right? Some of the things I will give you the material, some of the things wherever I feel that you need some help, I will be going through it, right? And towards the Hive, as I told you, promised you earlier, unlike the other batches, I will introduce you to S3 also, okay, which is the new way of storing the data. Okay? It's called S3, Simple Storage Service by Amazon. And now it is worldwide used. So Hive or S3 is what the people are using nowadays. Slowly, as you can see, maybe in another 2, 3, 4 years, you will see that Hive is getting slowly eliminated as HDFS is getting eliminated, and then new technologies and new things will come on the top of it. Okay, so Hive is a NoSQL database. What does that mean? Remember the CAP theorem. This is the fundamental theorem by which NoSQL databases are being governed. Repeating: consistency, availability, and partition tolerance. Out of these three things, only two can be satisfied at a time. If you want consistency and partition tolerance, you will go for OLTP or transaction systems like Oracle, etc., etc. If you want availability and partition tolerance, you will go for not only SQL or NoSQL databases. So, consistency is not important when you come to NoSQL databases. Okay, that's what CAP theorem is saying. And already we have seen one of the fantastic NoSQL databases. We applied MapReduce on the top of it, MongoDB. The next one is Hive. Later I will introduce you HBase. Hive, HBase, all these are related with Hadoop, whereas MongoDB is not at all having any relation with HDFS. You have seen that, right? They use JSON documents. Can you store JSON documents in HDFS? Yes, that is possible, right? But it is not MongoDB, that's what I mean. But as far as Hadoop is concerned, Hive and HBase are very much related with the HDFS file system. Okay? So, what is Hive? It is an innovation by Facebook. And what is the problem that Facebook encountered during the beginning days of Hadoop? You can guess. You have the HDFS and you have the MapReduce framework. And they liked it because they were the ones who are dealing with a large amount of data, petabytes of data. They wanted to do efficient processing. They taught MapReduce to all the people. They started writing mapper, reducer, etc., etc. Soon the problem came. The scarcity of resources. the difficulty in maintaining the MapReduce programs. Each and every time deploying the code into production, making the changes and all. And that was very difficult for the set of people who are data scientists, data analysts, etc. Their work was analyzing the data, not writing technology programs. So they asked a question, hey, till now we were having Oracle or MySQL database, we were able to write simple SQL statements. Suddenly you are coming up and telling that, okay, write MapReduce, which is very complex. Right? So what Facebook did, they took this HDFS and they did some magic and exposed this HDFS as a relational database so that there is no need of any MapReduce. You write simple SQL-like statements on the top of the data. The engine will take care of converting that SQL into complex MapReduce program. So you don't need to know anything about MapReduce. You need to know only the SQL statements. So you write SQL. Actually, it should not be called as SQL. You should call it as HQL, Hive query language. Very similar to SQL. Once you get familiar with this, you will understand what exactly it is. Right? Until that time, just understand that it is very, very similar to SQL. So what's the technology? Please look at that innovation. Complete world of developers became very, very useful to MapReduce and all the HDFS things that you learned without knowing a bit of what is happening in a mapper or reducer or anything. So you write simple SQL statements. So if you look at the maximum used, about 80% of the usage of Hadoop is through Hive, because it is very easy. And what's the advantage if you have a relational database kind of architecture? If I am giving you a JDBC driver, you can connect it from your Tableaus and BERT and all the reportings of the world. We'll show you that. If I am giving you ODBC driver, what is ODBC driver?
Open database.
Open database connectivity. What is the difference between JDBC and ODBC? Come on. JDBC is for Java. ODBC is for Microsoft applications. How will you connect? Microsoft SSRS, Microsoft Excel. And I will show you how we can connect Excel to your HDFS. What is the world's best BI tool so far encountered? Nobody could conquer even a bit of it. What is the best BI tool in your opinion? Excel. Nobody can come near to that. What if analysis is there? All your statistical functions are there. If you know Excel, you don't need any other tool. All kinds of analytics you can make in Excel. So if I am giving you a facility from which, or from Excel, if you can connect to Hive, what you can do? If you are a good Excel person, you know that macros and all those kind of things, you can write any analytics, any graphs, whatever you like. Right? So it opened up wide variety of possibilities. Most of our data in our companies are in Hive. What they do, if there are so many verticals, care is one vertical, maybe claims is another vertical, credit cards in a bank is another vertical, retail is another vertical, mortgage is another vertical, loan is another vertical. All these domains, at the end of the day, instead of creating a huge monolithic data warehouse, they are creating data warehouse. I told you many times that Hadoop can never replace a data warehouse. Because of the resiliency, because of the code rules, because of the transactional capabilities, because of the stability, because of the security, nobody can think of replacing an EDW, but for the analytical purposes, for the machine learning purposes, etc., you can create an alternate for a data warehouse, which is purely meant for analytical purposes. And what the people started doing, they started writing ETLs to copy the data into Hive. And today you see that every report, the systems, etc., are dealing with Hive. So the data is coming into Hive, right? That is what you call as a data platform in our companies. Mostly a Hive, some H-base. I'll tell you the difference later. So you join a company and they are telling that, hey, I want to do the Twitter analytics. The first thing that you are going to ask is, do you have a database in which your Twitter data is coming in? So if they are saying that, yes, we have an OLTP database, are you going to run the analytics on that OLTP database? Why? Because, why? OLTP systems are not meant to be for analytics. What will happen in the daytime if 1,000 queries are going to that OLTP database? It will happen what happened 1 week back. Right? So, nobody will allow you. Don't touch my OLTP database, they will tell you. It is clearly meant for only transactional systems. Customers are going to use it. I don't want a bank's online web application to be, with the database to be touched by an analytical purposes where hundreds of queries are running by analysts at the time. Right? I want that to be meant for ATMs, that to be meant for all the online web applications or online applications, correct? So, you will ask a question, okay, let me write an ETL. That is a very beautiful word. What does it mean? Extract, transform, and load. What is ELT then?
Extract, load, and then
where to use what? I know, the full form you will tell.
after loading the data.
So which one you will use? Why you should use ETL instead of ELT? Or why you should use ELT instead? So all these things we need to learn. Yes, it is extract, transform, and load. And what are the tools that you are going to use for ETL? Your talent, your ab initio, all these things. What are the problems? If you are using ab initio, the amount of parallelism that you can exhibit in ab initio is limited to only the servers in which ab initio is installed. So if they have paid for $1 million for 4 machines, your parallelism is limited to only that 4 machines. What our cores are supported by that 4 machines. What did you learn in Hadoop MapReduce? If I have 50 nodes, I can run 50 parallel connections on the ETL, right? That's what MapReduce is bringing you. So what is another way of looking at MapReduce? ETL. MapReduce is nothing but ETL. What did you do when you create word count? You took the data and you created the output in such a way that it can be consumed, extracted, transformed into key value pairs, and loaded into HDFS. ETL. Right? So all these people, and that is the biggest problem that I have, and that is the biggest problem in technology. The people who are working in ab initio or Informatica, then suddenly come and tell that, oh, I am a Hadoop programmer now, I am writing ETL. That approach is completely different. In ab initio, you might have queried directly by using an SQL, but here you have to take some considerations. What are the considerations? Referential transparencies, foreign keys, primary keys, synonyms, all those things might not be available on your Hive. So you need to do the proper change, transformations. Normally, Hive will be a flat, big database or table. You won't do much joins in Hive. Because the very inherent nature of big data is that, the less the number of joins. If you want to joins and if you want primary keys, then go for your RDBMS. So, what's the definition of Hive? What's the definition of Hadoop? Hadoop is a file system and a programming model called MapReduce on the top of it. We have seen it many times. Right? What's the definition of Hive? Hive is a data warehouse built on the top of HDFS. It's a data warehouse. The moment I say the data warehouse, it is not meant for OLTP. Instead, it is meant for OLAP, online analytical processing. Right? So that's what you will see in these slides. Okay? So just quickly go through. So you can see that a data warehouse infrastructure built on the top of Hadoop for providing data summarization, query analysis, etc. It supports ETL. In HDFS, whenever you store the data, is it schema on write or schema on read? Schema on write. Are you sure? Schema on read. Why are you saying schema on write? In HDFS, when you put the data, are you telling that my data should be written like this?
No, schema on normal database is schema on write, correct?
I didn't ask you normal database. Schema on read. NoSQL databases, MongoDB, schema on read. Always, whenever you are putting the data, you will just dump the data. Schema on read. Right? But Hive is a data warehouse. And I told you, Hive is a tabular way of looking at your HDFS. So is it schema on read or schema on write? It is schema on write. Are you getting the difference? Because the moment you are coming to table, and the moment I say table, you have to create a structure for a table. And that's what it is saying, structure.
So,
Access, sorry.
So Ravi, like as you said, Hive is just flat, nothing is there, so we don't have data marts similar to data warehouse or something.
You can create another Hive flattened table as a data mart on the top of that flattened table. It is not like a fact dimensional model. It is not like primary key, foreign key related. That's what I mean.
Okay.
You can have as many tables as you want. Normally it will be flattened.
But it won't be having data. If you want data mart type of thing, you need to have a copy or
Correct. You absolutely. And that's
Our-
what they're doing.
for maintenance. It is more.
It will be. It will be. Of course it will be. But fundamentally, when you want a data mart to be used for reporting, correct?
Yeah, because see,
And the moment you are coming to reporting, this is the answer.
relation.
Yes. What did I tell you? There is a specific purpose here. Analytics. Iterative queries. How many people, how many trending topics are there between the ages of 25 and 35 today in Twitter? How many people are subscribed to the latest tweet by so and so? The analytics, that is where you will use. Big data is all about that, right? Data marts, Immon model, Kimball model, factor dimensional model, sequels, normalized forms, Backus norm form. Oh,
What?
professional, they are all. Nobody can come near to that area, right? But still, don't think that I cannot create a report from Hive.
Yeah, okay.
I will create analytics, and that analytics I will store in a resulting table, and from that resulting table I will show. That's different from the way that you are creating your daily regular MIS reports. Are you getting the idea? Right. Next one. This is very, very important point, which till now for the other batches it was not relevant. That's why I told you. Access to different storage. See the beauty. This is where innovation. When Facebook created that, they could have easily created this particular relational structure pointing to HDFS. You know what they did? They created it in such a way that, okay, today you came up with HDFS, today I will give you a tabular view of this. Tomorrow you may come up with something else, ABCD. I will give you a tabular view on the top of that also. And that's the fundamental idea of S3. So when you have S3, the way that you are going to access S3 is through Hive. But at that time, that Hive is not going to point to HDFS. It will point to
S3.
access to different storage. And as I mentioned to you, the queries that you write on Hive without writing a single piece of code internally is getting converted into your MapReduce code that you wrote. So mapper, reducer, all those things will be created. You know, very close now. Now, what are the key building principles? As I mentioned to you in Facebook, faced with the scarcity of the resources, complexity for maintaining people. So, SQL is a familiar language. And in SQL, you know, you can, anybody wrote a custom user-defined function in SQL? Yes. So, you can do that. Leverage your procedures, triggers, packages. Ask him how many he is dealing every day. And performance. Of course, it is running through MapReduce. Okay. You have got databases, you have got tables, you have got partitions, you have got buckets. Don't worry too much now. We'll see all these things. You've got all the data types anyway. We are going to practice it. And the query that are going to be used is HiveQL. Don't say SQL, okay? So, is it an ANSI SQL compatible if somebody is asking you? No. There are limitations. So, if you take your Oracle query and you apply onto Hive, it won't work. If there is a connect by prior in Oracle and if you are taking it and putting it into your Hive, you are gone. So, you will look at what is the equivalent. You may need to do some refactor in order to make sure that it is working. Right? So, let's look at how Hive is used, and what we are going to do today, we will create a Hive table and look at the fundamentals. But before going to that, just to give you a brief overview of the internal architecture of Hive. Tell me, if I look at MySQL, you're all familiar with the MySQL. I'm connecting to MySQL. This is my local MySQL installation, don't worry. Okay, and I'm connecting to user ID and password. I got so many tables. So cards, games, all these are my tables. Okay.
Ravi,
Yeah.
this has to blink or it would be static only, right?
Yeah, it's correct. I have got lot of tables on the left hand side. It's very small, but let me write it down. Always, whenever you look at MySQL, you will see this. Other than your tables. Please listen. Other than your tables. Whenever you create a MySQL database, it will create this. And you will create tables and whatever you want on the top of it. Okay? Point number 1. Point number 2. MongoDB. Whenever we created, did you observe? It was always creating something called systems. When you looked at your collections, did you see? It was always showing system. What are these tables, Devraj? User dollar, DBA dollar.
Data dictionary.
Oracle will create something. Whenever you create any tables, what are all these? Why you need all this? Why every database has got something like this?
to crack an audio.
No database in the world can work without metadata. What is metadata? Data about data is called metadata. So, if Bhaskar is a valid user, Ravi is a valid user, Ravi can access policy table, Ravi can access cards table, Ravi can access retail tables. All these informations are stored in MySQL in information schema. In MongoDB it will be in system. In Oracle it will be there. That is why the DBAs will be querying that, okay, what is the privilege, where the granted privilege is, what are the privileges for this particular user, where are those things stored? And now comes our guy. We already mentioned that it is a relational structure on the top of your HDFS. And we already told that, okay, it is schema on write. We have to create a table. So, it needs a metadata. And where is Hive going to store all this information? You need to configure a separate meta store or a DB in order to tell Hive that use this DB as my meta store, and that is normally different from your HDFS. The reason is that your HDFS may go refresh or something like that, right? But whatever your meta store is there, it is intact. And it is look a little bit awkward also. I didn't like it. In one of my articles I wrote that the only database in the world where the meta store is in a separate database and the data is in another database. You won't see it. In Oracle, will I store the metadata in MySQL? No, right? In Oracle I will store. So in some design papers, I have written that. I don't like that. But there is a meta store needed. Are you very clear about that? What is the meta store that we are using in Cloudera virtual machine? So let's find it out, right? So how are you going to find it out? Give me your system. I'm going to unshare this. Don't stop anything there.
Yeah.
Give me this thing. Please. Okay. This is internal, okay? Detected internally.